Alrighty, so Chapter 10, Question 22. Cassie knows she has to factor and use a zero product property to solve for the roots of the equation x squared plus 1.5x minus 2.5 equals 0. And I actually think on yours it's equal to y, but we know that she's going to use a zero product property, which means we're plugging in a 0 for the y. She's confused, though, about what to do with the decimal. Suddenly, Claudia blurted out, "No, Cassie, I think there's another way. Can't you first rewrite this equation so that it has no decimals? Then it will be faster and easier to factor. And we won't have to use even the quadratic formula." So the first question is, how do we rewrite the equation to get rid of these decimals? Well, this kind of is going to go back to some of our fractional knowledge that we gained back in the day. We'll just say that. Maybe 5th grade, 4th grade. Now, the key thing here is that we need to understand that we want to get rid of these decimals. But we can do a lot of different things. We could add a value to move this negative 2.5 to the other side of the equation. We could multiply every single thing in this equation times a number. We could factor out something like we've talked about before. Maybe if there was a negative in front of the x squared, or if there was a number that all three of them shared. But for this problem, we have decimals. And what we first need to do is ask ourselves, if I were to take this number, 1.5, and convert it into a fraction, or maybe even a mixed number, what would it turn into? This one would turn into 1.5, or 3 over 2, if we were to write it into an improper fraction form. Now I'm going to do the same thing for this 2.5. I know it's negative, but actually the negative doesn't really matter at all. So I'm going to write it as 2.5. I could also rewrite this, and some of you might be wondering, how do I know it's 1/2? Well, I know that it's actually 2 5/10. And then I'm going to simplify that 5/10 because both of them can be divided by 5. And that's how I go back to that guy, which is 2.5. And then I could also write this as an improper fraction, 5 over 2. So that's how I know, and this is going to be really helpful to me later on because I'm going to need to know what should I multiply this equation by in order to get the decimals all gone and to get rid of the decimals from this equation. And that's what Claudia is suggesting here. No, Cassie, I think there's another way. We can rewrite this equation. So that's a key thing there, is we're going to rewrite this equation by multiplying by a common term. Previously, we've been working so much on factoring out anything that these three have in common that it's kind of challenging to think about like, okay, we're going to do the exact opposite of that now. We're going to actually multiply by a common term here. Okay? So how do we rewrite the equation to get rid of the decimals? Well, we're going to multiply by a common term. And yes, you should be writing this in your notebook as well. We're going to multiply by a common term to get rid of the decimal. Now, in order to get rid of the decimal, we have to know what the denominator of this fraction is. In this case, the denominator of both of the fraction equivalents is 2. So what we're going to have to multiply by in this problem is 2. We'll multiply by 2 for this problem. That's not true for all problems, but for this problem, both of our decimals turn into a denominator of 2. So we're going to multiply by 2. There are other equations that are going to turn out to be a fourth or a third or something like that. You get the idea. But if whatever the denominator is, that's what we have to multiply by to obviously get rid of it, right? The opposite of dividing is multiplying. So we're going to have to multiply by the inverse of the denominator. We're going to multiply by 2 for this problem, and that's it. That's our sentence. Okay. So how do we know what we need to multiply by? Oh my gosh, I'm so silly. I wrote that up there instead of on the line where I meant to write it. So how do we know what we need to multiply by? We'll multiply by 2 for this problem because it's the denominator value when we convert, again, the decimal into a fraction. And it looks like my pen is dying, so I'm going to go ahead and trade out colors here. All right, so let's go ahead and work this one out. We have x squared plus 1.5x minus 2.5, and of course we set it equal to 0. We set it equal to 0 because it was equal to y in the problem, and therefore we know that we need to use the zero product property. So here we go. We're going to take this whole entire equation, all the things, this guy, this guy, this guy, and this guy. There's 4 different things in this problem, and we're going to multiply them all times 2. I always write it up top like that so that I remember to distribute to every single item in the problem. I need to make sure that I multiply by 2 to every single thing. That's going to give us 2x squared plus 3x minus 5 equals 0. Now, what I think that Cassie probably did is she looked at this original equation, drew her diamond factor to see if it was factorable. She got negative 2.5x squared and positive 1.5x, and she was like, ugh, that looks like the worst problem ever. And I would agree with you. That looks terrible to try and factor. And I'll give you a secret, like that this problem actually is factorable. We just need to be able to do it in maybe numbers that are more familiar to us, which is why we multiply by 2, eradicate the decimals, and now we have a nice, easy integer problem. I'm going to recreate my new diamond factor. Again, a times c, so negative 10x squared, positive 3x down there in the bottom, and voila! We have our 2 values. We know that one of them has to be positive, one of them has to be negative because there's a negative on top. So we're going to go with 5x and a negative 2x. We're then going to go ahead, so again we take that, we draw our diamond factor. Now we're going to go back over here, create our generic rectangle, and fill in our a and our c. 2x squared, negative 5, positive 5x, negative 2x from our diamond factor. And then we ask, what do they have in common? These guys have an x in common, these guys have a negative 1 in common, these guys have a 2x in common, and these guys have a positive 5 in common. And there we go. 2x plus 5 times the quantity of x minus 1 equals 0. This would be so great if the problem asked us to put this problem into factored form. But that's actually not what the problem asked us to do, was it? It asked us, Cassie has to know that she has to factor. How do we rewrite? What do we need to do to solve for the roots? Okay, so please, 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 I keep saying this, I know, but you want to make sure that you are reading that problem carefully. We're solving for the roots. You would only get a 1 out of 3 on this problem so far because we haven't done it completely correctly yet. All right, so our next step would be to use the ZPP, set them equal to 0. We have 2x plus 5 equal to 0. And we've got x minus 1 equals 0. Subtract this 5 from both sides. 2x equals negative 5. Divide by 2, and we get anything divided by itself is 1. So we got x equals negative 5 halves. Or what's our other option? We're going to add 1, and bam, we're done. Alrighty, and that, folks, is how we get full, complete answers, full, complete points, and show all of our steps for simplifying a problem where we have to rewrite and get rid of that decimal. Now, the same thing could have applied, and I do just want to show you this kind of problem. If the original problem for this one had been x squared plus 3x over 2, or probably what it would have been, hold on. It would have been x squared plus 3 over 2x minus 5 over 2 equal to 0. We would do the exact same thing. So don't let this kind of like scare you off. Anytime you have a fraction in the denominator, they actually took a step for you towards solving the problem. Now, you just have to multiply by 2 to get rid of those denominators. You don't even have to think at all about how to convert from a decimal to a fraction and figure out the denominator. They took that step away for you, and bam, all you got to do is multiply by 2. It's the same exact process whether you're given a decimal or you're given a fraction.